Sure.
Yeah, go ahead.
Hope everyone is able to see my screen, my share. Yeah, good morning all. I am Vikram. I work for Intel and I am part of OpenBMC team at Intel. And I have been working with Intel for the last 3 years. So mostly I was working on the firmware security related stuff at Intel. Okay. Okay. So and then apologies for the last week's session cancellation because at the last minute because unexpectedly I was not well and I couldn't take it up, and so I could make it for this week. Okay. So this is going to be a basic overview on the SPDM and how we are going to, on a top level, how we are going to integrate with the OpenBMC stuff. Okay. So if we look at the scope and agenda of this session, right? I'm just going to, we are just going to look at what is SPDM and what is the SPDM message flow and what is going to be the what is the SPDM specified message format, and then we'll slightly touch upon the our open SPDM code base and add a basic slide on a open BMC and open SPDM integration, how we can leverage the open SPDM into open BMC to integrate, to get it integrated with the MCTP, which is already existing on open BMC. Okay. So stop me at any point if you have any doubts or questions. Okay, so this is a basic generic fundamental slide which I wanted to show for the who are new to the SPDM or platform security, platform firmware security, right? So we typically will have nowadays on any platform, we will typically have a ROT, root of trust device, which will be responsible for the authenticating the firmware components on each platform, and it will typically have a capability of accessing the firmware components of the platform and I mean making a trusted computing base, right? Like it can authenticate the firmwares and it can allow the firmwares to work once after the authentication is successful. So we have a kind of chained ROTs as well, and which is a kind of extension to the platform ROT, and we chained ROTs will be particularly present on the devices, so such as PCI adapter cards or something. And so we basically call the entire platform authentication as the platform attestation, and the extended device attestation is called device attestations. Okay, and the platform ROT is responsible for establishing the trusted communication and trusted authentication of these firmware components. So, so the SPDM is seen as a kind of extension to the existing ROT's capabilities, which is nothing but like it can access the in a ROT, any ROT can access the BIOS or BMC firmware, and it can independently authenticate before it is being allowed to boot, right? And this SPDM is on the similar lines, and it allows the more handshake communication-wise authentication, wherein ROT will be acting as a requester, and the rest of the devices will be acting as a responders. And it so in with respect to that, SPDM gives a specification what all commands need to be sent to the devices by the ROT, and what are the responses to be given by the devices as a responder. Okay. Any questions on this slide? Yeah. Hope most of the guys will be aware of this this architecture. Okay. Moving on to the next slide. So here, okay, I'm touching upon the basics of the SPDM, and how is SPDM is defined and what is SPDM. So basically, SPDM specification gives a requester responder protocol specification, wherein the requester is always the initiator of the communication. Um, so basically, the requesters will act as the challengers or attester, right? Okay. So the requester will be sending all the attestation comment to the responder, and the responder has to respond with the respective responses for the commands. So if we look at the requester's responsibility, basically it will discover and identify the responder, and by some means of getting its capabilities and a version, and yeah, so once after getting capability version and capabilities, it establishes a trusted communication with that, and from there on it will start authenticating the responder with its measurements, and yeah, with its measurements. So along with this, SPDM also provides additional specification for mutual authentication, wherein the requester will be able to attest the responder requester as well. So that is made available in SPDM 1.1, and the other one is secure communication. This is the additional feature of specification of the SPDM. So this can be used commonly for any secure communication between MCTP devices. Okay, uh, I think it can be extended to any devices, not only to MCTP devices. The secure communication. So it is most of the encrypted way of communicating and the session-based communication between um, two devices. Okay.
Quick question,
Yeah.
Vikram. So
Yeah.
when you mentioned like mutual authentication,
Yeah.
so that means like both of them should be provisioned with the same public key?
Yeah, so the provision thing is that this SPDM allows the platforms to have a trusted provisioning, and wherein that happens in a manufacturing zone, right? If in that case, both should be provisioned with the same public key, and that is one scenario. In another scenario, the key exchange will happen in the runtime, and wherein the key exchanges will be done during the runtime. The provisioning would have not happened, and the keys should be matching.
Yeah, since you mentioned like say PCIe cards, right? So we may not have control on the device side.
Yeah.
For
So they should have they need to have the same root certificate, and so we will have a root certificate and the leaf certificate, right? So devices will have leaf certificates, but that needs to leaf certificates needs to be authenticated by the root certificate.
okay, which means like say the same vendor should be providing both sides. So we cannot just plug in a PCIe card coming from a different vendor.
Yeah. So that's implementation specific, and we need to have these
Okay,
root key provisioned in that scenario. Yeah.
got it. Thank you.
Yeah. So, and that is the base idea of like the fundamental idea of this SPDM also, like we cannot use a untrusted card or unknown card on a trusted computing zone.
Okay.
Yeah. Thank you. So yeah. So as I was telling, the entire SPDM specification works on the request response model, and so SPDM specification gives a lot of commands to do this and establish a trusted environment, right? So in with respect to that, it has defined several commands, so which will be useful for authenticating the responder or as well requester as well. And I'm showing here a fundamental basic diagram which I have taken from the SPDM specification. So any SPDM communication will start with get version, and that is the beginning of any SPDM authentication process, the get version should be successful. Then only the SPDM further SPDM attestation will be going on. Okay, so get version is the command for checking the version compatibility between the requester and responder. And once that is successful, and it will go for the get capabilities command. And get capabilities commands is used for detecting the capabilities of the responder in terms of the signature and hash algorithm supported by the responder. So this will be used by the requesters to set the authentication base at the requester side. So which algorithm to use and which signature should be used, right? That is the get capabilities command. And negotiate algorithms. So wherein so requester may be having the capability of supporting many different hash algorithms and signatures, right? But responders may not be able to support, or in either other ways also. Responder may be supporting too many hash algorithms, but requester may not be able to support that. So in that respect, it will send a command to negotiate the algorithms, wherein they settle to a common algorithm, and so which will be further used for further authentication. Okay, and yeah, so from once these three commands are established and successfully, yeah, so, it was successful, then that means the further attestation will be on. Okay, any time, right? These three commands are the basic things which needs to be tried when establishing the attestation process. Okay, and here and get version is used. Get version is also used as a reset command. With get version command, so the any previous ongoing commands or any process will be reset to the again to the beginning. So here they use the get version command as well as a reset of the flow. Okay, and so once after the capabilities are detected, and then the requester will send sorry requester will send the get digest and get certificate commands to get the keys of the responder. So this is basically to retrieve the keys supported by the responder in the runtime. Uh, for a platforms who has got provisioned in a factory or in a trusted zone where the public key is already provisioned, right? So these two commands will not be used, get digest and get certificate. So they will be using the provisioned key for the further further authentication and attestation. So uh, challenge auth is something which command where the requester will send a nonce to get it signed by the responder. It will be to ensure that the keys are same and it is passing the the first authentication by the requester with the responder. Okay. And next comes this get measurements. So get measurements is the actual measurements done for the firmwares. So this will typically be hash of any firmware. For example, in case of BMC firmware, the hash of the BMC firmware component will be exchanged with the requester, and then it will be verified by the requester. Okay, so that's the use of the get merges command. And key exchange RSP is something which will be used for the secure communication and for mutual authentication. Okay, I'll not be covering much onto the mutual authentication and secure communication. So we are actually primarily targeting specification 1.0. And as I said, key exchange and key exchange response will be typically used by for secure communication and mutual authentication process. Okay, so as I was mentioning in the beginning slide, the mutual authentication is used for the attesting the requester by the responder. Okay, so they have again the specification again have given certain set of commands to how a responder can attest the requester. Any questions here?
Here, I think you say the secure session, right? And then does
Yep.
it mean like when you send a get version command, this whole thing will be teared down? The whole secure session will be teared down and go back to the reset when somebody sends a get version?
Yeah, good question.
No, Sai. So this get version, everything is the earlier SPDM establishment of two devices, right? But secure communication channel will happen only after this kind of stuff. So till they mentioned like the yellow box mutual authentication, right? So after that one, you can have secure communication and secure session is established only after that one. The earlier one is not a secure one, but still you in order to do the it is the establishment of session, you can assume in that angle.
Yeah, so I'm trying to understand that get version, like how, in what condition it resets the whole thing. So what does it mean by, like, say, when you send a get version, it's a kind of reset?
Yeah, so basically the get version is used as a handshake for resetting the previous already in progress responses, right? So whenever a responder gets a get version command, and it will truncate all previous ongoing commands, and then it will start again fresh with the get version command. You're getting it right, like, yeah. So it's basically it's basically used as a handshake for the beginning of initial attestation process. Yeah.
Just understand, like, say, if you send like negotiate algorithms and the response did not come, is there a timeout for that? And then, like, say, when you send a command.
We have a timeout. Yeah, we have a timeout. So within the
that,
timeout, after that, if you send get version again, it starts from the beginning. So responder. So if so, it is like for an implementation, right? If responder is maintaining any state mission, and it can use the get version command as a state mission initialization.
Okay.
Just to add here, so the get version is like as Vikram said, it is a reset condition, but it will be accepted by responder only after timeout, particular timeout. In between timeout, if it receives, it is like a illegal message. It will just drop. It has to drop. Otherwise, it will cause some kind of denial of service, right? Somebody can hack and send the get version continuously. So it is there is a timeout defined in the spec. So once this timeout happens, then get version is received, then it will reset to the starting condition.
Great. Yeah, that makes total sense actually. Yeah. Denial of service. Okay.
Yeah. Thanks, Emma, and thanks, Richard. Yeah. So going to next slide. Yeah, this is a basic on the how an MCTP packet looks like, and many of us would have looked at it already in the specification. And so SPDM is a part of MCTP packet, and it will be coming somewhere here in message data, and rest all things will be specific to the MCTP, and MCTP parser will be utilizing these things to find out whether it is a SPDM or PLDM or NCSI something. So typically we will have MCTP will have a destination address and the command code, and this command code is something static, and it will be always 0F, and byte count and source address and rest of the destination related endpoint ID and source ID. And along with that, it will also have a message integrity check bytes, typically the PEC, right? And yeah, so it also has the message type byte. This basically distinguishes between the different types of MCTP message types. Okay, so for SPDM messages, this message type is 05, and for secure message types. This is going to be 06. Okay. Yeah. So and when we look at the SPDM message, right, like it will have a 4 bytes of header, and rest all will be the SPDM payload. Okay. And that starts with the message type, and the rest of the things will be request responder code, and basically it's a request code or response code. Request code means when the message is coming inside to the SPDM, right, it will come with a request code, and when we are responding back, it is the response code should be placed here. And the payload, like as we were discussing, the payload will have the respective commands data, like in case of get version, for example, when we are responding to get version, the version details will be given as part of the payload. Okay, I'm moving on to the next slide. Okay, so here, yeah, so with that previous slide, so we looked at what is what is SPDM and what is the format of its message and what is its flow, right? And here comes our code, SPDM code implementation architecture. And I would like to thank G1. I think G1 is also on call. G1 is already has implemented this open SPDM code, and which is available on the GitHub. And we are leveraging it, and we started implementing it in the OpenBMC, and we'll be integrating this open SPDM with our existing OpenBMC MCTP code. Thank you, Jivan, for joining. So here, like, so we are seeing like it's well organized code, and if we look, so this is a except from the G1 code from the design document, and so if we look at this, it is well organized code, and for each layer we are mapping it to the each specification, and where exactly that each specification goes into which module, right? And that is clearly demarcated, and it is layered, so that anyone can take this code and integrate into their application and make use of it. Okay, so the code is architectured in a way that we have a requester library and a common library and a responder library. So these are the entry points to this SPDM code, and which will have a registration of the callback functions and context initializations. Okay, so once that is done by an application, so you will have your integrated functions will be called, and you will be able to also get notified about the SPDM messages. So the requester library provides a code for all the request commands, and it is placed in a way that each command has its own source code. Okay, and it is like that, and the same way for the responder library. And so if we say like example get version and get capabilities and negotiate capabilities, and each and every command has its own source and how it is handled, all those, how it is handled, and it will be there. Yeah, sorry. Oh, sorry. So common library is something which is a kind of integration library for the below layers of the establishing a section or the transport, integrating into the transport layer. The common library will do that, and so which will be which will be used by both requester and responder library. And yeah, so this is typically will be having integration to the secure library or transport library, and also utilities functions for the responder and requester libraries.
Quick question on this device driver. You know, at the top you said, is it a kernel level or it's a user level?
It's a user level
device driver.
Yeah. So okay, it's a user level driver when it comes to our OpenBMC. So basically, like this code is being done for EFI, and it is getting leveraged for OpenBMC, right? So with the technology, it is there, the device driver.
Okay. Okay.
We have not yet moved to kernel level driver, Sai, not
Okay.
at least from the PMCA tools point of view. So the MCTP layer are the binding. We are maintaining it in user level stuff. But yes, our plan is to move totally to kernel, which is going to happen. But probably in Q1 time frame, I think something like that is what we are planning to start. Not sure, not now.
Got it. Yeah. And also, like, does it respond to like multiple devices? So, like, for example, if you have multiple PCIe devices, is it scalable? This model as
That's
it
right.
is?
So the current PMCA, that is MCTP level implementation, whatever we have is the MCTP daemon is capable of accepting from multiple interfaces, physical interfaces. When I say I2C, PCIe kind of stuff, and it advertises the devices accordingly, so that you will be able to respond even in a single physical interface to the multiple device. You will be able to communicate and query its capabilities.
Great. Okay.
This is from a PMCA point of view. Now SPDM will be integrated along with that one, so that when the binding layer receives something, MCTP layer will consume it, and further that one, if the MCTP message type is SPDM, then it will be given to this SPDM requester lib, so that the SPDM can respond to the messages, and that's what we are planning to integrate.
Great. Awesome.
Yeah. So when so other thing is that the secure communication and the transport transport layer integration is part of these two source bases, a secure message and transport layer. So we'll be mostly integrating with these layers with our existing OpenBMC library. So yeah, so if we look at how we are going to integrate with our OpenBMC, right? So we already have an existing MCTP daemon and libsmbus MCTP, right? And we are implementing an SPDM daemon, and which will be waiting for the signal from the MCTP daemon and the SPDM messages, and from there we'll be making a calls to these already by registration with a SPDM get response function in the responder library. So this will be for a request, and for sending any request from the SPDM daemon to the other devices, we'll be utilizing the requester library, and SPDM daemon will be registering a call for that, and it will be again using the libsmbus MCTP calls for making the physical layer calls. Yeah. So with that, I come to an end to this overview of this. And yeah, so I think we definitely need a deep dive into each one of these modules when we are doing the integration. And we'll be getting to know the integration difficulties, and we'll be solving some of the issues while integrating with the SPDM with our existing OpenDMC MCTP. And I think we will probably need to have one more session with the deep dive into this. So any questions here?
Yeah, I have a lot of questions, but I think I'll wait for the deep dive because I think this is very complicated and it'll be interesting to see how you implement it.
Yeah. See, sure. Sorry, but anything like we would like to know your questions if something which makes us to think on a design perspective, right?
Yeah, I was wondering, like, say, most of our daemons are talking with IPCs with the dbus. Of course, it has some latency, but here I see most like a traditional Unix model with all the signals and other things. So is this because of efficiency or because we are trying to fit in like existing UFI code into OpenBMC?
Not really, because if we look into it already existing MCTP daemon and libmctp, right? It does both dbus call and also signaling. it does support both, and in fact we are using PLDM also. PLDM daemon also is running based on a signal input.
So
Okay.
yes, to your question, right? Yes, you are right. We actually have that dbus model, and luckily for MCTP, two versions as of today exist, right? One is dbus, another is socket based approach. That is, once MCTP packet is received in the MCTP daemon, it can advertise the packet to the consumer or whoever it has to be forwarded, right, through a socketing mechanism. And that is in our current OpenBMC community stuff. But unfortunately, the socket as of today will not be able to solve all the problems. That is, it will be able to send and receive to and fro messages, but when the number of devices, that is MCTP devices increases, the problem is you will not be able to tell a new device discovered, or a device has been removed from the system, or some kind of notification. We don't have a good model in socket yet. So right now there is another stuff in which we send it through dbus. Yes, of course, the dbus is having certain latency, but with multiple instances of MCTP daemon per physical interface, the latency will be restricted to like extra 3 milliseconds kind of stuff. But anyway, our ultimate plan is to move to socket and doing the notification. When I say notification, like new MCTP devices has been discovered, say due to a plugin of PCI add-on card, we have discovered a new MCTP device, and it has to be notified to the MCTP PLDM layer so that PLDM can go ahead and further query it. So in order to do that one, ultimate our plan is it will be socket, and the signaling will be based on netlink kind of stuff. But unfortunately, we have not yet into that stage. So this has been discovered as a part of our OpenBMC PMCI work group, where both Intel, IBM, and other people are joining. But unfortunately, it is not in US convenient time. We wanted to start one with US convenient time, but we have not yet made that progress. We'll look into that one again.
The reason I said was like there is another reason, like it's not just a PCI card hard plug, but sometimes the device gets reset and you would like to kind of re-authenticate during the
yes.
Because
And
firmware
as
could
of
have
today,
changed.
yes, agree. So as of today, the SPDM is not yet integrated into OpenBMC, and that is what Vikram is looking into that one, right? And as I said, the right side block, right, apart from that SPDM daemon, rest everything is like a library. So you can integrate in all the places however we want. But in order to do the secure communication, what at least the initial discussion, whatever so far we have is, we will include this libSPDM decoding library, that is secure channel packaging library, inside the MCTP daemon itself, so that we can avoid one extra dbus hop. Just because we received a packet in secure channel, right? We don't need to do a extra hop, and then from there to PLDM layer, that hopping we can avoid. So MCTP layer will receive, the MCTP daemon will receive the packet from the physical interface through library bindings. If it is a SPDM secure channel message type, then it will call the libraries to decode that one exposed by the libSPDM or libopenSPDM. And once the packet is decoded, then MCTP daemon will just forward the packet in the similar manner how it has to be exposed to PLDM or whatever it is.
Okay. Yeah, that makes sense actually. Yeah, having this already it is latency sensitive. So. Yeah. Okay.
Yeah. Thanks, Richard.
Thank you.
Yeah. Any other questions?
Yeah, by the way, this 1.1, is it public, right? SPDM 1.1, or is it still in the?
It's released.
Yeah, it's released.
1.1 is now released.
Okay. Yeah, because I think not many of people are in the DMTF, members, so they may not get access to these specifications which are like in progress. So, anything that we should be aware of, like any new features that we are planning in the upcoming versions for SPDM?
So next version is in plan. I think probably today or yesterday that OCP one related to SPDM 1.2. They might have announced a few things. But right now our immediate stuff, whatever we are targeting is request responder model, that is authenticate attesting, saying that the device is yes what the device we are intended to do communicate with, and our next progress immediate requirement is secure message channel. So in that priority only we wanted to attack. And 1.2, at least I don't envision we will have it in open BMC at least in next quarter or in next 1 or 2 quarters.
Okay.
Until otherwise someone is having some priorities and willing to contribute, right?
Got it. Thank you.
Yeah, I also have captured the references what we have. I think this probably might help to go over all this and to get educated. I think, yeah. This will capture the DMTF spec and the OCP specs and the links to the our open SPDM code and the open SPDM design document. I think we are at the end of it, and if we have any more questions, we can discuss. Otherwise, we are done for this meeting.
Yeah. Any questions from others? Okay. Looks like yeah. Thanks a lot, Vikram. I think I will look forward to your presentation material. I'll post it on the wiki.
Sure, I'll share with you. Yeah, thank you.
Thanks for a great session.
Yeah, thank you all for joining.
Thank you all. Bye.